Today we're going to look at dilations. Now, a dilation usually makes the graph either wider or thinner. And what we need to do is look at dilations in both the x-axis and the y-axis. So let's begin with dilations within the x-axis. So to do this, I'm going to draw a basic square root graph. So when I draw a square root graph, I'm just going to put a coordinate on there. So it comes from there, and it goes like that. Now let's pick a coordinate, 1, 1. Okay. So of course, when so it's y equals the square root of x. So when x is 1, square root of 1 is 1. So we've got that. So 1, 1. Now what I'm now going to do is I'm going to dilate this in the x-axis. That means it's going to go in the y direction, because when you stretch something, when you're doing a dilation from this axis, you're actually stretching it this way, so it's towards the y direction, so it stretches that way. So it's a stretch, I guess, in the y direction, but it's from the x-axis. So I'm actually going to draw the graph of y equals 2 square root of x. So let's do the same point when x is 1. When x is 1, square root of 1 is 1, times 2 is 2, so the coordinate here is 1, 2. And what we can see is it has doubled, so it's the same in the x direction, in the x coordinate, but it's stretched in the y direction. And this is what we call a dilation from the x-axis. So let's just generalize this. If this value of constant is 2, let's call it a. If I want to dilate a function, any function, and I want to dilate it by a constant in the x-axis, so stretching in the y direction, we basically multiply the function by the constant at the beginning. And that gives us a stretch in that direction. So I'm just going to do another example. What I'm going to do is I'm going to dilate the graph of y equals x squared by a scale factor of 3 from the x-axis. So if I draw the graph of y equals x squared, and here's the y-axis, if I dilate it, I'm going to follow the general form. So remember we said whatever f of x is, in this case it's x squared, in order to dilate it by a scale factor from the x-axis, I need to apply this. So I'm going to multiply, because it's a scale factor of 3, it's going to become 3x squared. And when I draw that, what's happened is the graph has actually gotten thinner. I'm just going to do a coordinate. So let's just pick the coordinate on this graph. So 1 squared is 1. So we know that the coordinate there is 1, 1. Now let's use the same x coordinate, 1, and we'll apply this. 1 squared is 1 times 3 is 3. So that coordinate is 1, 3. What we can see is by applying this, it's stretched in the y direction, but obviously from the x-axis, and we can see that the y coordinate has multiplied by that scale factor of 3. I'm now going to look at what happens when you dilate from the y-axis. So for this, I'm going to use the graph of y equals x squared again. So if I draw the basic graph of y equals x squared, what we find is when we dilate it from the y-axis, it's actually a stretch in the x direction. So what happens is the graph actually gets wider. So I'm just going to draw a dotted line for the actual one. This is actually going to be the graph of y equals x squared over 9. And what we're going to do is have a look at what the scale factor actually is. So I'm going to pick the same coordinate 1, 1. Now let's have a look at what has happened when the coordinate is, when the y, because we're doing, of course, dilation from the y-axis. Let's look at what happens at the coordinate when y is 1. So when y is 1, let's have a look. 1 times 9 is 9. Square root to get that gives us x is 3. You see I'm looking only in this direction, negative 3 will be over here. I'm just looking at the positive. And what we can see is that there appears to be a scale factor stretch in the x direction by 3, which of course is coming from the y-axis. Now what we're going to do is look at the general form for this. When we've got a function y equals f of x, if we want to dilate it from the y-axis, means we'll stretch it in the x direction. The general form looks like this, where a is our scale factor. It's actually f of x over a. I'm going to do another example using the square root graph again. So I'll just clear some space. Okay, so I'm going to apply this rule to this question. So it says dilate the graph of y equals square root of x by a scale factor of 2 in the y-axis. So I'll apply this rule where a is going to be 2. So because our graph is y equals root x, or f of x equals root x, sorry, let's just change that notation. We then just need to apply this to do f of x over a. And remember, it's a substitution thing, so I'm substituting 2 in for a. So we do that, we get the square root. Remember, wherever you see x, you sub this in instead, so it's x over 2. And that becomes a graph. Now, I'm actually going to sketch that to check that it is stretched in the x direction by this scale factor of 2 from the y-axis. So if I just quickly sketch up, and I'll pick the same coordinate I like to use when x is 1. So here's our square root graph, that's the square root of x. Let's go with 1, 1. Now let's have a look at what happens with the y coordinate. So if I just do a dotted line, okay, we've got, let's have a look at when y is 1 in this particular case. Yeah, you can see it's been stretched in the x direction from the y-axis. There's the coordinate. So when y is 1, you get 1 equals the square root of x over 2. We square it, 1 squared is 1, and we get x is equal to 2. We're multiplying by 2. So the coordinate is actually 1, 2. And look what we can see. The y coordinate has doubled with the scale factor of 2. And that's pretty much everything we need to know about dilations.